This is a class 12th RD Sharma solution. We are taking chapter 19 VSAQ and this is for indefinite integrals. Very short answer questions. Now the main key is we have already completed 32 exercises. Few of those exercises contained almost 70 questions. So this exercise will take us from 1 to 32 exercise and all the concept will be used here. 1 plus cot x divided by x plus log x sin x dx. Now since this is VSAQ or short answer question, we generally see the denominator and we would like to get the numerator out of it in the indefinite integrals. So there are certain options like if you have under root, you need to eliminate that thing. So all those concepts will be used here. In this case, we will take this x plus log sin x as a t. Now let me tell you that t, you can take it as p or u, any letter from a to z which is not matching with what is given in the question. So that can be used. I'm using t, you can use p, but trivially we are using t. So this is dt by dx. We are differentiating with respect to x. This will be 1 plus log sin x is 1 by x, that is 1 by sin x, and then sin x will be differentiated, which will be cos x. So what do we get? We are getting 1 plus cos by sin is what? It's cot x. But 1 plus cot x is along with the dx, so we'll take this dx on the right. So 1 plus cot x dx will be equal to dt. So the integration will become something like this after taking into consideration the replacement or t which we have taken. It will be the numerator, which is 1 plus cot x dx. We already got dt, and x plus log x was taken as t. And dt by t is directly log modulus of t plus a constant of integration. Now initially we took t as x plus log sin x. So the final replacement will be replacing the t with the original thing. That will be log modulus of x plus log sin x, and inside the modulus sign plus a constant of integration. This is your final result. Now those who have already known me, that I already say about the logic and the concept, but the actual solution I generally show you like this so that you can refer it later. And all this English thing and the symbols are very important, vital, integral to the solution of mathematics. Next one is e raised 3 log x multiplied by x to the power 4. Now all these questions, they will need a lot of understanding about the exponential and logarithmic functions. That means if this e to the power 3 log x, now you already know this, we have discussed this, that if you have a log x, it simply means it's x to the power a. That means it's log x to the power a. You can call it in another way, that in a general terms, log x to the power y is y log x. The power comes in front. So the concept is like this. So this 3 log x will become what? With this discussion, it will be log x to the power 3. Now you have x cube and x raised 4. But still, there is one more thing as far as exponential functions are concerned. E to the power log x cube. Now e log e to the power log e cancels out. That is, if you have e log m, say, you can take any letter. I'm just explaining you that if the base is e and you are raising it to the power e log, so this gets cancelled, only m will remain. So the answer will be x cube in this case, the result actually. So we'll take this x cube. So whole e raised 3 log x can be written as x cube, and once it is known, this x cube will be multiplied by x to the power 4. You have a dx here. X cube into x raised power 4 will be x raised 7. And x to the power n integration is known to you. Let me tell you here, because it is going to come again and again. Integration of x raised n is simply x raised to the power n plus 1, and this is with respect to dx. So x raised n plus 1 divided by n plus 1 plus constant of integration. So whatever n is there, that is in this case 7, you can use it. So it will be x raised 8 divided by 8 plus constant of integration. This is your integral. Now this is how you're going to write it, because I told you very deeply what all concepts are used here, but this is how you have to actually write it. Next one is x square sine x cube. Now if you take x cube, the differentiation will give you x square. So we will take this x cube as t, will differentiate it dt by dx. This will give you 3x square. This dx will go here on the right and 3 will bring in the denominator. So dt by 3 will become x square dx. Now this x square dx we will take together and we'll replace it by dt by 3. So the integration will become something like this, dt by 3, 3 can be taken outside, 1 by 3. Then we have sine x cube, and x cube was taken as t just now. So this will be sine t. So let's take this as sine t dt. So we'll integrate it now. Sine t integration is a negative cos t, 3 remains here, plus a constant of integration. But still there is one more thing needs to be done, which is t equals to x cube has to be replaced. So the integration will be minus cos, in place of t will have x cube, divided by 3 plus a constant of integration. That's your final result. So how you are going to write it, that's what I'm showing it to you right now. You can follow this. Now, there are various questions where there is one thing which we put as t, the differentiation comes out by itself. So if you take this 10x as t, please remember there is one more question just coming with this same scheme. So this t, if you take it as 10x, and when you differentiate it, dt by dx will be what? It will be sec square x. This dx can be brought on the right. So this dt will be equal to sec square x dx. This integration will become like this. Sec square x dx will be dt. You can just write dt in place of sec square x dx, and then 10 cube x, t you can take. T cube will be 10 cube x. So t cube will come. Now this x raised n integration kind of thing we can apply here. It will be t raised 4 plus c. Final replacement of t as 10x can be done, and this integration will be like this. It will be 10 raised 4x divided by 4 plus a constant of integration. And this is how this will be done, and this is a very easy question if you have done all the exercises of indefinite integrals. E raised x sin x plus cos x. Now this, if you remember, when we were differentiating or when we are learning this differentiation, just multiply this first. E raised sin x plus e raised x cos x. Now you need this. How can we get this? From our previous experience, we know that we can put this t as, so this t will be equal to e raised x sin x. When you differentiate it, it will be dt divided by dx. This will be equal to, we will apply the product rule, e raised x sin x will be cos x plus sin x. This e raised x will be e raised x. Now you see the similarity, actually it's this whole is dt only. So whole expression we have actually got after putting t equals to e raised x sin x. So this whole will be simply dt, and the integration of dt is simply t, and this will be t plus constant of integration. This t is e raised x sin x, which we initially imagined or we thought. E raised x sin x plus c is the final result. Now this is how you are going to write it, and this all the symbols and let all this is your responsibility, which I show you. Now we have just done a question like this, and I pointed it out that this question is going to come again. So same thing we are going to do here. We just put t equals to 10x. Then we differentiate dt by dx. That will give you sec square x dx. That is dx I am taking on the right hand side. So this whole sec square x dx is simply dt. 10 raised 6x is simply t raised 6, because t was taken as 10x. So let's take this. It will be simply t raised 6. This whole has become dt, and when we integrate, it will be t raised 7 divided by 7 plus constant of integration. T was earlier 10x, which we put here, 10 raised 7x divided by 7 plus a constant of integration. So this is how you are going to do this, and this is for your reference for later. Now this 3 plus 2 sin x is in the denominator. Numerator is cos x. Now if you take sin x equals to t, you will get a cos x for sure. But you will get 3 plus 2t. You don't want that because it will again increase the effort of solving this kind of question. So rather than taking sin x as t, just take this t plus 2 sin x, because 3 and 2 will eventually be easier to maintain when you differentiate. So when you differentiate dt by dx, this 2 sin x is there, cos x will come after differentiation. So cos x dx already got, this dx goes here, t I'm bringing on the denominator. So cos x dx will become dt by 2. So this integral will become, cos x dx will be dt by 2, so dt will come here, 1 by 2 here, 3 plus 2 sin x. So we have taken this whole as t, so dt by t, and this will be half, dt by t will be what? It will be log modulus of t plus constant of integration. In place of t, replace it with 3 plus 2 sin x, which was earlier taken. So half log modulus of 3 plus 2 sin x plus a constant of integration will be the final result. Now this is how it will be completed. All the symbols on the modulus signs and sins and all this has to be done. Now we have just done a question like this, and we need to get this e raise sec x. Just multiply this first. So this e raise x sec x, then we multiply e raise x sec x with 10x. So this will be e raise x sec x 10x. Now what do we consider, or what do we take so that we get whole of this expression as we just did in the previous questions? So let's take e raise x sec x after, just deliberating that what we have done in the past, the differentiation activity. So dt by dx will be e raise x sec x 10x. I'm applying the product rule. Sec x e raise x will be e raise x. So these two terms are exactly same. So this whole of the term which is given in the question can be written as just dt. So again you are just integrating dt. So you are just getting t here plus a constant of integration. But we have taken t as e raise x sec x, so we can write it here plus a constant of integration. This is your final result. So this is how it will be done, and this is how it will be written, and take it as a reference. Try it yourself. All these questions are already been done by you. Now there are two questions which are almost similar, and we have this log x raise n. So log x raised y is what? We have learned that it is y log x. So n can come in the front as an exponent, you can, as a coefficient you can say. So this will be n log x divided by x. And then what is the use? When you take log x equals to t, 1 by x can be achieved. That is dt by dx will be 1 by x simply. Dx can be taken on the right. So dt has become dx by x, which is already given in the question. So we can do the replacement here. Dx by x can take place of dt, or dt can be replaced like this. Log x is t, n can be taken out. It will be simply t square by 2. N is already there plus a constant of integration, and t was taken as log x, which needs a final replacement. This will be n log x to the power 2 and plus a constant of integration. So this is n by 2 log square x plus a constant of integration. Now how this has to be done, again, this reference is very important for those who just want to do by themselves. Now this question is very straightforward because we have just seen that log x differentiation is 1 by x, which we know earlier also. So we'll just take simply t equals to log x. When we differentiate it, dt by dx will give us 1 by x. So dt will come as dx by x. Now this dx by x is already there, which can be replaced by dt. Log x was taken as t. So this dt, it's simply t raise n. So it's a general solution. X raise n, we were integrating earlier, x raise n plus 1 by n plus 1. In this case, x is taken as t. So t raise n plus 1 by n plus 1 plus constant of integration. But one more replacement is required. T was taken as log x. So you can write it as log x raise n plus 1 divided by n plus 1 plus a constant of integration. Now this is how it will be completed. I hope that this is very clear to you. You can do it by yourself. Alright. Now in this question, certain things you need to recall. Exponential and logarithmic. That is e raise log, but the base is e. Whatever is there after that, the thing which is after that only will come. That is e log e will vanish. And how does this happen? We have already taken much description on exponential and logarithmic stuff. So this will only sin x, this only will be cos x dx. So e raised log sin x is sin x, cos x was already there, and there is a dx already there. Now we can get sin x from cos x, we can get cos x from sin x, but we don't generally deal with the negative sign. So we'll take t equals to sin x, because when we differentiate dt by dx, it will be cos x. That means dt will be equal to cos x dx. So from here to here, we can write dt, and sin x was taken as t. So the integration will become t dt, and this will be simply t square by 2 plus constant of integration. So what is t? T was taken as sin x earlier. So this will be sin square x divided by 2 plus a constant of integration. Now how we are going to do it, it's in front of you, and I hope you'll be able to solve it easily. Now sin cube x cos x, we have just seen in the previous question, the latter part of that question answers this question and the questions which are coming later to this. That is, if we take t equals to sin x and we differentiate, which we have already seen, dt by dx is cos x, that means the cos x dx can be directly taken as dt. So from here to here we'll put dt, and sin x is t, so t cube it will be. So the integration will be equal to t cube and then dt. So this can be integrated, t raised 4 divided by 4 plus constant of integration. T was taken as sin x, so it will be sin raised 4x divided by 4 plus a constant of integration. And now if you have understood the previous question, this question will be just peanuts for you. But there is another question which is coming up, which is just the repeat telecast of what we have seen. Here only the sin x and cos x have swapped or changed places. So t we'll take as cos x, dt by dx will be equal to negative sin x. So cos x differentiation is negative sin x. So minus dt will be equal to sin x dx. So sin x dx you can just write here, and this sin x dx is already there, so we can replace it by dt because we have taken t, and this cos raised 4x, because cos x is t, cos raised 4x will be t raised 4. This will be t raised 5 divided by 5 plus a constant of integration with a negative sign. But still we need to replace t by cos x for the final answer. This will be the final answer. Alright, now the way to write it, the three questions we have just done are almost similar, and this is how you are going to go about it. This question also not very similar to the previous question, but almost identical. What I'm saying is that only tan sec has changed, cos from sin cos. But if you take tan x and this is sec square x and then sec x, that is, I'm writing sec cube x as sec square x and sec x. I'll just change the places. Sec square x first and then sec x tan x you can write. Why I am writing this? Because you know that this sec x will be differentiated. I will take t equal to sec x because sec x tan x is the direct differentiation of sec x. So I'm taking t equals to sec x, and after differentiation dt by dx we'll get sec x tan x. Dx can be taken on the right, dt will be equal to sec x tan x and dx. So this whole is already dt and sec x was taken as t, so it will be t square. So we are just going to integrate the basic stuff, which is t square dt, and this will be simply t raised 3 divided by 3 plus a constant of integration. But t was taken as sec x, so just replace it. It will be sec cube x divided by 3 plus a constant of integration. So this is how we are going to go about it, and even if it is sin cos or tan sec x, the idea of solution remains the same. Now this question and the question which is coming is almost similar. We have already done it in the differentiation and integration already. So what we'll do here is we will divide numerator and denominator by e to the power x or e raised x. So I'm dividing it by e raised x. This becomes, the numerator will be e raised negative x. This also e raised negative x. This becomes 1. Now what is the benefit? Because e raised x or e raised negative x will always be e raised x or e raised negative x respectively when you differentiate them. And don't take e raised minus x as t. Take all of it, 1 plus e raised minus x. When you differentiate it, 1 will vanish, it will disappear, and e raised minus x will come, and then the differentiation of negative x will be negative. So negative 1. So this e raised x negative x dt will be minus dt you can write. That is, when you want to replace e raised x minus x dx, it is equivalent to negative dt. So I'll take this negative on the left hand side and replace e raised minus x dx by dt, and the denominator was taken as t. Now you see dt by t is simply log t, which we have done multiple number of times. Now t replacement is essential, which is 1 plus e raised minus x inside the modulus sign with a log with a negative plus a constant of integration. Now sometimes people wouldn't like this negative, so it goes to the power of 1 plus e raised minus x. This will be simply like this, 1 by 1 plus e raised minus x plus constant of integration. So this is how it will be done. Please remember, division by e raised x is the key, and 1 plus e raised minus x as taking t will be done here also. So let me just show it to you, because I'm quite confident that you'll be able to solve it if you refer to the previous question, which we have detailed explained. The same thing is done here. Again, it's very straightforward question. Tan inverse x, when differentiated, it will give you 1 by 1 plus x square dx directly. That is, t equals to tan inverse x, and when you differentiate this dt by dx, it will be 1 by 1 plus x square. Dx can be taken on the right, so dt will be equal to dx by 1 plus x square. Now this dx by 1 plus x square can be written dt directly. So this integration will become, tan inverse x was taken t, so it will be t cube. This whole will become dt. Again, a very simple integration. It will be t raised 4 divided by 4 plus c, and final will be tan inverse x. We will have to replace, in place of t, it goes to the power of 4 divided by 4 plus constant of integration. Now how are we going to solve this? This is in front of you. Okay, so next question, again same thing. When you take tan x equals to t or any value, any letter, when you differentiate it, sec square x will come. And please remember, we'll not take tan x equals to t, because 5 added is just you can say diversion tactic by the examiners, because this t equals to 5 plus tan x, if you take, differentiation will eliminate this 5, only sec square x will come. So dt will be equal to sec square x dx. So the numerator, directly you can take dt. So this integration will become a dt, because sec square x dx already got, and 5 plus 10x was taken as t. It is t raised 4. And I hope that it's quite clear to you how to do this. T raised 4 will be taken upstairs. It will be t raised minus 4. It will be t raised minus 4 plus 1 divided by minus 4 plus 1. And this will be t raised minus 3 by minus 3. Minus 1 by 3 can be taken out. This t negative 3 can be taken in the denominator with a positive, that is positive power 3. So this will be negative 1 by 3 t to the power 3 in the denominator. So let me write it like this. Negative 1 by 3 t cubed. T was taken as 5 plus 10x. So it will be just 5 plus 10x in this case. So this raised to the power 3, because it was t cubed plus a constant of integration. So this is the final result. So the solution is in front of you. This is how we are going to solve it. And this is a kind of question which we have already taken care in the earlier discussions. Now sin x plus cos x is already given to you. Now from that you can infer that this 1 plus sin 2x can be written in the form of sin x plus cos x. And we need to get rid of the root. 1 can be written as sin square x plus cos square x. Sin 2x can be written as 2 sin x cos x. What does it mean? It's sin x plus cos x whole square. So a plus b whole square, which is a square plus b square plus 2ab, that will give you 1 plus sin 2x. Now when you take the root of this power 2 will get eliminated. Okay, that is, we have sin x plus cos x in the numerator. We'll get sin x plus cos x in the denominator also, but it's square inside a root. So let me just do it in another way. So this root will eliminate the power 2. So the numerator and denominator will be identical, which can be cancelled. So you just have to integrate dx, because everything will get eliminated just by the rules or the axioms of trigonometry. X plus c will come, because integration of dx is x. Now if you are aware of trigonometry, it's a very easy solvable in less than 15 seconds. Now log x, the base is e. Now we have to use the formula here. That is the result which we have earlier seen. I'm going to apply isolate here because log x cannot be integrated in this way. We ought to have some other thing which is not present, which is present but it's not being written, because every number is always multiplied by 1. So 1 multiplied by log x, take log x as first function and 1 as the second function. So first log x will come first function, then we'll do the integration of the second function, which is 1 dx minus integration of what? First the differentiation of the first function, then integration of 1 dx, that is the second function, and when all will be done, then we'll integrate it finally. So let's do the second part first. 1 dx will be x, log x differentiation will be 1 by x, this gets cancelled, only 1 will come, that is you just have to integrate dx. So the second part will give you x directly. From here to here, only x will come. And what about the first part? X from integration of 1 dx, log x is already there, then minus x plus constant of integration. Now since e is specifically given, it's your duty to write it in the answer also. You can take x common if you want to make it more simplified. Log x minus 1, base e is important, plus a constant of integration. So this is how it will be done. It's a different set of questions from the earlier questions we have attempted, but you can try it by yourself. Now a raise x, e raise x. You need to notice that the variable is x, but a and e both are constant. So I'm writing 2 raise x into 3 raise x. That simply means it's 2 multiplied by 3 to the power x. That means 6 raise x. So this can be written like this: a into e to the power x integration. Now if you are not comfortable with a into e, you can just assume it to be some t or p. So essentially you are writing a and e dot e, which is nothing but a constant. It's not a variable. T is not used as a variable here. It's just a constant. You can write it as a, you can write it as t. It's up to you. The concept should be clear. So just call it as p now. You can take any of it. So what is a raise x or p raise x dx? It's a raise x divided by log base e a. So this a is taken as a e here, which I have written just p to show you there are multiple possibilities, but ultimately it will be a e raise x log base e a e. Okay, this is the answer. So this is just a one-step solution if you are aware of the previous discussions. Now this seems a bit complicated, but it's not. See, any power, if you have e raise a plus b, simply means you are multiplying e raise a into e raise b. You are adding the power a and b. So e raised to x square, this is first one, and then second one is e raised log x. ln is log base e. Now e log base e x, we have seen that it will give you only x. So this whole second part will become x. Again e raised to x square is there, and we are knowing that x square can give you x directly. That is, if you take 2x square equals to t, because x square can give you x. So 2 into 2x, I'm differentiating both sides now with respect to x. So dt by dx is 2 into 2x, which means 4x dx is dt. So we just need x dx. So this can be written as dt by 4. So in place of x dx, we are writing dt by 4. I'm taking 1 by 4 outside. And e raised to x square can be written as e raised t, because t was taken as 2x square. But there is nothing with e raised x. E raised x will come only. And what was t? It was 2x square. So the final result will be e raised t, with t can be replaced by 2x square divided by 4 plus constant of integration. So this is a good question, 1 marks or 2 marks question. And the only thing is the first part. Integration is not important, the concept is important. Now we have it again, it looks quite typical, but it's not, because we have e raised x log base e a. X goes to the power. You already know that, because it can be written as log base e a raised x. And I told you e log e gets only what is coming after that. So a raised x will come. So only a raised x will be there. The next one is what? The second part, which is e raised a log EA. So a goes to the power. This can be written as e log ex, a goes to the power. Again, this will get eliminated. Only x raised a will come. So you just have to integrate these two. Alright. X raised a also has a direct integration result, and a raised x also has a direct integration result. So we are going to integrate them separately, and since these are the standard results of integration, we'll write it here. So it will be x raised a plus 1 divided by a plus 1, because a is nothing but a constant, and a raised x is simply a raised x divided by log base ea. So a raised x log base ea plus constant of integration. These two constants can be combined, written as a simple constant c. So this is how the result comes. So this is a simplest way in which it can be shown, the result. Write a value of. Now we have cos x and sin x and also log sin x in the denominator. So we will take this log sin x and we'll try to get this cos x and sin x in some way. So if we place this t is equal to log sin x and then we differentiate it dt by dx, this will be 1 by sin x and then sin x will be cos x. So this dx, if it goes on the right, this sin x, cos x, dx, all that has come, and cos x by sin x into dx will be equal to dt. So that will replace here. So it will be dt divided by cos x dx, sin x is dt, and log sin x we have taken as t. So this log modulus of t plus constant of integration will come. And now let's replace this t, which is log sin x, and you can keep it in the bracket plus a constant of integration. Now how this has to be done, this is in front of you, and since it is VSAQ, you will be able to solve it easily. Now this question, we have denominator, we'll try to get the numerator from the denominator. What does it mean? When we take t equals to the denominator, which is a square sin square x plus b square cos square x, when we differentiate this, it will be dt by dx, constant remains unchanged. Sin square will be 2 sin x and sin x will be cos x. Similarly, b square 2 cos x and cos x will be minus sin x. So I'm just changing the sign in between. So what is the benefit? We have 2 sin x cos x, we have 2 sin x cos x. 2 sin x cos x means sin 2x. And they are in both the terms which we are talking about. So this will be sin 2x. You can take this sin 2x outside and you have a square minus b square. So this sin 2x dx, we can get it from this expression. If you take dx on the right and a square minus b square in the denominator, dt by a square minus b square will be equal to sin 2x dx. So the numerator we have got, and we need to replace it by dt by a square minus b square. So this will be dt divided by, I'm taking this constant a square minus b square in the denominator outside, and this t will come because we have assumed it to be. The answer will be log modulus t plus c, and constant is already there, 1 by a square minus b square, and t will be replaced by the initial thing taken, a square sin square x plus b square cos square x plus constant of integration. Keep it in the modulus. 1 by a square minus b square will be in front. Now this is the solution for you, or the reference. You can try out by yourself if you are not actually going to listen to what I'm saying. You need to do it all by yourself next time. Now we have t equals to 3 plus a raised x. When we take this, dt by dx will be what? This 3 will be 0. A raised x will be a raised x log a in the denominator. Now this denominator is just a constant. This dx goes on the right. So this will be a raised x dx, and then dt can be multiplied, or this log ea will come. So what I'm suggesting is this a raised x dx and dt will be multiplied by log ea. So let me write log ea outside, dt is there, and then we have this as log modulus of t. This constant of integration hasn't come yet. We will write log modulus of t plus c. The final will be 1 by log a, and this will be log modulus of 3 plus a raised x was taken plus constant of integration. This is your final result. So this is how you can do it. Alright. Just take t equals to 3 plus a raised x. Now we just have one option in this question. We can take either x log x as t, or 3 plus 3x log x as t. So it's up to you which you want to take. The better way is to take the whole denominator as t. So t equals to 3 plus x log x, dt by dx differentiation will be what? 3 goes 0. I will apply the product formula. X log x will be 1 by x plus log x remains like that, x will be 1. So this will be 1 plus log x. So numerator we have got 1 plus log x dx is the numerator. So this dt will be equal to 1 plus log x dx. That can be written in the numerator, just dt will come. Denominator 3 plus x log x, we have taken it as t. This will be log modulus of t plus constant of integration. Now t was taken earlier as 3 plus x log x plus constant of integration. This is your integral. So this is how you can solve it. This is the reference for you for your later. Now this sin x divided by cos cube x. Now cos x can give you directly sin x. It's simply integration of 1 by t cube. So when you take t equals to cos x, and when you differentiate it dt by dx, cos x will be negative sin x. Now dx can be brought on the right, minus on the left, so negative dt will be equal to sin x and dx. Now this is the numerator. So sin x dx will be negative dt. So negative you can bring out, dt you can keep in the place of sin x dx. Cos cube t will be 1 by t cube. Now this t cube, when it goes up, it will be t raised minus 3. When you integrate this, this will be t raised minus 3 plus 1 divided by negative 3 plus 1. And this will be t raised minus 2 divided by minus 2 minus half, that is. And this t raised minus 2 will go in the denominator 1 by t square. So minus 1 by 2t square will come. And t is cos x. So you can write cos square x in this place. Now you can keep it like this because the question is in sin and cos form. This is the final result actually. But in order to match it with the R.D. Sharma solutions, you can just bring it cos squares up. That means 1 negative and minus half, negative will get cancelled, so positive will come. 1 by 2 cos square x. Cos square x can be taken up. It will be sec square x. So this is also another way to write it. So this cos square x can be taken up as I just intimated. Sec square x by 2 plus constant of integration is the final result. Now logic you understood. It's a very simple question and this is how you are going to write it. All these have to be followed. Now sin x minus cos x by under root 1 plus sin 2x. This kind of question we have already attempted and done. So 1 plus 2 sin x. 1 can be written as sin square x plus cos square x. Sin 2x can be written as 2 sin x cos x. That will be square. Square will get cancelled. And that can be sin x minus cos x. If you take the denominator, numerator will come automatically. So I'll encourage you to solve it by yourself. It's a somewhat different kind of question, because you have to write sin x minus cos x as t so that you can get the numerator. But when you remove the root, the plus minus sign will come, because if you have under root x square, when you replace under root with this one, plus minus x will come, because x square can be negative x square plus x square both. So the earlier question also which we have done in this exercise, you can just include this plus minus, which is important here. All other concept remains the same. 1 by x into log x to the power n. So log x goes up, it's log x to the power n. Denominator has x and this log x goes up, it will be negative n. Please understand, I have not written negative. It's log x to the power minus n divided by x. Now always log x will give you 1 by x, so that is what we have to take. So this log x negative n, x to the power n is simply 1 by negative 1 by x to the power minus n. Or you can say anything raised to the power negative will go in the denominator. So this log x goes up, it will be negative n, and we have x in the denominator. So when you integrate this, when you take this t equals to log x, when you differentiate this both sides, dt by dx will be equal to 1 by x. You can take the dx upstairs, so dt will be equal to dx by x. So this dx by x is dt here. And log x raised minus n. Log x was taken as t. This will be t raised minus n. You just have to integrate this t raised minus n, which will be t raised minus n plus 1 divided by negative n plus 1 plus constant of integration. So this final replacement has to be done in place of t. The final answer will be equal to log x raised. Let us write this as 1 minus n, which is more I friendly. So I am writing 1 minus n, numerator denominator plus constant of integration. This is your final result. So this is again a very easy question, and you can solve it by yourself, and this is the reference for you in front of your screen. Now this question and the next question, they both are similar, so you need to understand this question very well. The next question which is going to come, which we are going to show you, is e raised x cos x bx. So exactly same thing will happen here. So let's do this one by one with total details, and the concept which we are going to use, you will just see. If you have done integration earlier, it will be very nice to understand that ILATE will be applied. In ILATE, the last one is exponential and the previous one is trigonometry. So I hope that you know which function has to be taken first function and which has to be regarded as the second function. So this first function will be sin bx and the second function will be e raised x as per the ILATE rule. So this is sin bx integration of e raised ax dx minus then whole integration of what? First the differentiation of the first function, which is d by dx of sin bx, and then the integration of e raised ax. So what will come? This is sin bx, this will be e raised ax, and when you integrate this, ax will be differentiated and the value will be put in the denominator. That is why we have a in the denominator. Sin bx differentiation is cos bx. Again, bx will give you b, and that goes again in the along with cos bx actually. So it will be b cos bx. Then multiplied by what is e raise x dx, already done. E raise ax divided by a. Now what do you see here? This I will be what? Let's rearrange this first. E raise ax divided by a, sin bx is there, minus this e raise x and cos bx will remain inside, but the constant we can take outside. So b by a will go outside, and inside the integration e raise x cos bx. So the next question, what I'm going to do just now will be this one. So please give all your concentration here. So let's call it as I1. So we are integrating e raise ax cos bx here. We'll apply isolate here. So this will be again same thing which we have done earlier. Cos bx integration of e raise ax dx, and then the differentiation of the first function which we have taken as cos bx. So d by dx of cos bx will come. Then the integration of e raise ax will come. So cos bx, e raise ax will be e raise ax divided by a. Cos bx will be minus sin bx. So this minus is already outside, so we'll make it as a plus. This will be sin bx divided by into b. And then e raise x ax divided by a from the first thing. And then we have to integrate this. But this b by a can again be taken outside. And when you take it outside, this sin bx eax is what? Initial thing. We started with I equals to e raise ax sin bx, which we have come again. We are revisiting it again. So that will be multiplied by b by a, has to be taken on the left, but only after we multiplied by negative b by a. Why? Because this is whole is I1, and in place of this which I rounded, we just have to write I. So if I remove this, because this is what we have integrated, we have to keep multiply b by a by cos bx into e raise ax by a. So e raise ax by a into cos bx, and then plus b by a into I. And I was the earlier thing which we did. So what I am trying to suggest here is we have to multiply this b by a I plus e raise ax by a cos bx. So let me write it clearly if you haven't understood what I was saying. Sin bx e raise x by a minus b by a, and then we have inside this cos bx e raise ax by a plus b by a I. So this I, what we have again revisited, has been placed here. So this multiplication has to be done. This whole after b by a is actually I1 which we got. And inside I1 we have again got I. Now let's multiply this inside. I'm multiplying b by a with both the terms which we have just integrated here. This I goes left, I minus b square by a square I, that is plus will come because it will get added there. So this will come like this. If you remove this, this goes on the left. So I'm writing this a square minus b square by a square, and just take this a square, multiply this on the right. So multiply a with on the right, there are two terms left now, sin bx e raise x by a and minus a is a b by a square. So multiply this a square here. So a square gets cancelled from the second term, a and a square gets cancelled for the first term, and e raise ax you can take common. So a sin x minus b cos bx e raise ax by a square minus b square I equals to this one. This is your final result. Now whatever we have discussed is in front of you, and I hope you have a better idea of this. There's only slightly one change. It is not a square minus b square, it is a square plus b square, because we multiplied with negative. So negative when comes in the left, it will be positive. So there's a slight change here or correction there. Now let me show you the result for the second question also, means 32nd question, which has to be done exactly like that. So you just try this, and I hope you'll be able to convincingly completed. Now in this question, what you see here, this is a direct result which we have already proved in our theory. That is, if you write this like this, integration of e raise x, then fx plus f dash x. So we need an f dash x. If it comes, then we can apply the formula. So fx, if we take 1 by x, and if we differentiate this f dash x, what are you going to get? Negative 1 by x square. And this is exactly what we have in this question also. Negative 1 by x square, f dash x. Now we are ready to apply the direct result which we have discussed earlier. And the result will be e raise x remain like this. And then we have fx plus constant of integration. So let's write e raise a x and fx as I just told you, we took it as 1 by x. So e raised x into 1 by x, that is e raised x by x plus constant of integration. That's your integral. Now in this question, we have to take a prior notice. What can give you what? So if we take this t equals to e raised ax fx, when we differentiate this dt by dx, let's take any of this as the first function or second function. We will apply the product rule. In the product rule, first we take the first function, differentiate second function, then we add again the second function and the differentiation of the first function. So fx remain like this here, e raised ax will be e raised ax, then ax will be differentiated, a will come. Now if you take e raised x as common with these two terms and just change the position, swap the position of other two terms inside, afx plus f dash x will come. If you multiply this original will come. So this dx I am bringing on the right, dt will be equivalent to what we have in the question. So this whole question, after taking t equals to e raised ax fx, we have got it as dt. So you are actually integrating dt only, which will come as t plus a constant of integration, and t was initially taken as e raised ax fx, that we are going to replace just now. So e raised ax fx plus constant of integration is your final result. Now this is how this will be done. This is a very straightforward question. Just only if you can put t equals to this one, then you are able to solve it. Now we are using a certain direct formula here, integration of 4 minus x square. So this is under root a square minus x square if we integrate. So I am actually integrating this with respect to dx. Dx is outside the under root. Okay. Now when we integrate this, we are going to get x by 2 under root a square minus x square, and then we have a square by 2 sine inverse x by a plus constant of integration. Now we can change this question into this form, that is 4 can be written as 2 square minus x square and this inside a root. So wherever x is there, keep it like this. Wherever you get a, you can replace it by 2. So this x by 2, which is x by 2 only, under root a square minus x square. So 4 minus x square will come, minus a square is 2 into 2, 4 divided by 2 is 2. So only 2 will be the outcome, 2. Then we have sine inverse x by a. So sine inverse x divided by 2 plus constant of integration. Now there is a slight change. What do you think is an error here? Plus this will be plus. So I'll just change this as plus because this is the standard result. So one mistake I committed. I'm very sorry for that. Let's make it as plus. So this is how it will be done. So this is a plus. You need to remember this formula and direct answer can come. Under root a square plus x square kind of formula we can apply here. So we have under root a square plus x square. Let's write the formula, generic formula, which is x by 2 under root x square plus a square by 2 and log base e, we can write it as ln modulus of x plus under root x square plus a square. Now this expression can be written like this, 3 square plus x square. So we'll take x as x and a as 3. So in this formula, just replace a equals to 3 wherever you encounter it. So we are eventually integrating this under root 3 square plus x square dx x by 2, which is this one, x by 2 under root x square plus a square, that is 9 plus x square plus a square by 2, 9 by 2 ln modulus of x plus under root 9 plus x square plus constant of integration. This is your final result. Now this is how this will be done. This is a clearer version of the solution which I can show you. And this is how you have to follow the result. Again, the direct formula we are going to apply here, under root x square minus 3 square we can write. Before that, let's know the formula or revisit the formula again. Under root x square minus a square dx, and this will be x by 2 under root of x square minus a square minus a square by 2 and ln, that is log base e, modulus of x plus under root x square minus a square. So x square minus a square will come plus a constant of integration. So wherever we encounter a, we can write 3. Why? Because x will be x and a will be 3 here. So x square minus a square, which is x square minus 3 square. A we will take as 3. So x by 2 under root of x square minus a square, which is 9, 3 square minus 9 by 2 ln modulus of x. This will be plus under root x square minus 9. plus a constant of integration. So this is your straightforward result. We are just applying the formula which we have learned in the earlier discussions. So just use those formula and you can get the result easily. Now x cube can give you directly x square. So this is very simple. You can take just 1 plus x cube as t. When you differentiate this, dt by dx will be equal to 3x square. That means if you want to replace x square dx with something, it will be simply this x square dx will be dt by 3. 3 you can bring it in the denominator. So we have dt by 3, I equals to dt by 3 in place of x square dx and 1 plus x cube, which is t only, which we have taken. dt by t is simply log modulus of t, and t we have taken as 1 plus x cube earlier, so you can just replace in here. So let's write the final answer 1 by 3 in place of log modulus t. Log 1 plus x cube will be written, so ln log base e it is 1 plus x cube and plus a constant of integration. This is your final result. So again, very straightforward question. If you have done previous exercises well, this will be a piece of cake for you. Now again, we will just see the denominator. If denominator is able to provide us the numerator, if it at all this is the case, this will be simply a log modulus t question. I am suggesting take t equals to x cube plus 6x square plus 5, and then dt by dx will be what? This will be 3x square plus 6 to the 12, 12x, and when you take this 3 as common, x square plus 4x will come. So dx can go on the right. This will be dt by 3. You can bring this 3 down here on the left. So x square plus 4x dx is already in the numerator. This is dt by 3. So this integration will be integration of dt by 3. 1 by 3 goes out. Denominator whole x cube plus 6x square plus 5 can be written as t. dt by t is simply the log modulus of t. T was earlier taken as x cube plus 6x square plus 5. So we'll just replace this t by this term and final answer will be written. So 1 by 3 ln log base e, which is inside the modulus, we'll write this original expectation as t, which is eventually x cube plus 6x square plus 5 plus a constant of integration. So this is your final result. So this is the reference you can use. Now there are 3 questions coming like this. So I hope you'll be able to do all of this, because if you take under root x equals to t, you are going to get 1 by twice under root x. So dt by dx of under root x, that is a differentiation of 1 by under root x, is 1 by twice under root x. You already know that. Let me just give you a hint. X to the power half we are differentiating. Half x to the power half minus 1 will come. Half x to the power minus half, which is half x minus half will come in the denominator. X half will come. So 1 by 2 under root x is going to come. The dx will go on the right. 2 you can bring on the left. So this will be 2 dt equals to dx by root x. Now this whole will be 2 dt. So this integration will become something like this. 2 we can take it outside. Dt will remain inside. This will be sec square x, sec square t. Alright. And sec square t has a direct integration, which is tan t. So 2 tan t plus constant of integration is going to come. Now just replace t by root x, because which we have earlier taken. So 2 tan under root x plus c is the final result. So there are 2 questions which are coming up. So this question again, just refer to this solution, and the next question will be sine, then will be cos. So sine root x by root x, again the same thing. Just take root x equals to t. Other things will follow smoothly, and it will be simply the integration of sine t, which is negative cos t. Next question is even easier, because just have to take t equals to under root x. So this dx by root x will be twice of dt. So you just have to integrate cos t, which will come as sine t, and replacement of t as under root x. So this is very easy question. 1 plus log x whole square divided by x. Now we can get this 1 by x from 1 plus log x. That means if you take t equals to 1 plus log x and we differentiate it dt by dx, 1 will be 0. Log x will give you 1 by x. Now dx can be brought on the right. So we got dt equals to dx by x. So this whole dx by x we have got after this replacement as dt. So this integration will change something like this. We have dt and 1 plus log x whole square. This is 1 plus log a, which is t, so t square. So when you integrate it, it will be t cube by 3 plus a constant of integration. And then we have to replace, because what we have assumed t needs to be replaced here, 1 plus log x raised power 3 divided by 3 plus a constant of integration. So this is how we are going to solve it. The only thing is 1 plus log x can give you 1 by x. Sec square 7 minus 4x. Don't worry about 7 minus 4x. Sec square x dx can give you directly tan x. So you don't need any assumption or any change. It's a direct result. So this is tan 7 minus 4x plus a constant of integration. But after that, you have to differentiate this 7 minus 4x, and the differentiation of 7 minus 4x will give us negative 4. So let's differentiate this. This will be negative 4 only left, and that needs to be divided. So we divide this negative 4, and that's the final result. Only one step answer. So this is how, because integration of sec square x is directly tan x. This is from where we derive it. Now log x by x, integration of log x by x. Log x, take t, dx by x, directly you will get. So dt, t, you just have to integrate this, t square by 2, t was taken as log x, so log x whole square by 2 plus a constant of integration. Now this is also a direct formula, that is, if you integrate a raised x, this will give you a raised x divided by ln a plus a constant of integration. Now what is a here? It is 2. So in this, just replace a by 2. So 2 raised x ln 2 plus a constant of integration. That's your final result. Now this is a direct result as I just suggested. This is how you're going to do it. 1 minus sin x cos square x. See, there are two ways to do it. Cos square x can be written as 1 minus sin square x. 1 minus sin square x can be written as 1 minus x, 1 minus sin x, 1 plus sin x. 1 minus x, 1 minus sin x gets cancelled, but still you are left with 1 plus sin x in the denominator. So that's an issue. So better is to divide this, which I am doing right now. So 1 by cos square x minus sin by cos square x. 1 by cos square x is sec square x, and this sin by cos square x, as I just showed you on the right, it will be tan x and sec x. Now when you come down to this part, the two parts which you see on the left and right, they both are the direct result. Sec square x will give you tan x, sec x tan x will give you sec x plus a constant of integration. This is a direct formula. Okay, so this is the result in front of you, rather than doing the way I was telling you, because it will land you in nowhere. So this is how you're going to go about it. Again, the same approach will be followed here. X cube divided by x square minus 1 by x square. That is, I'm dividing the numerator into two parts along with the denominator in both the parts. So x cube by x square and 1 by x square we are integrating. X cube by x square will be x dx. 1 by x square, you can do it separately. It's just x raised minus 2. So in both the cases, you have to apply the integration of x to the power n. So x to the power n plus 1 divided by n plus 1 will be the result. So x to the power minus 2 plus 1 by minus 2 plus 1. So x raised minus 1 divided by minus 1. So you'll get minus 1 by x here. So you can just add this. Minus minus will be plus, plus 1 by x will be there, plus a constant of integration. So this is your integration direct result. Alright, from here we started. So this is how you can do it. As I told you, it's a direct result, so you don't have to worry about it. Just separate them out in two parts. Here it's an observational question. If you observe very closely, x minus 1 can be achieved from the numerator, because this x cube minus x square, if you take this x minus 1 common. So when you take x square common from the first two terms, x minus 1 will come. The x minus 1 remains untouched. Now divide both the parts with x minus 1. So you have x minus 1 in the denominator. Now this cancel this out. You get x square here, plus you cancel these out, x square, and then you have x square and plus. See, it's plus. So I'll just change the sign. So this is x cube by 3. So this is a plus. I have changed it to plus now. This will be plus. Integration of dx will be x only plus a constant of integration. So the formal way, you need to know how to do this. This is the way you are going to do it. Alright. The reference is important. Now tan inverse gives you direct result as 1 by 1 plus x square. And this is e raised tan inverse x. So it is e to the power. So let me write it in a formal way. E raised tan inverse x divided by 1 plus x square integration we are doing with respect to dx. So when you take t equals to tan inverse x, and when you differentiate this, dt by dx will be equal to 1 by 1 plus x square. Dx goes on the right, so dt will be dx divided by 1 plus x square. Now this dx by 1 plus x square can be replaced by dt, and e raised tan inverse can be replaced by e raised t, because tan inverse was taken as t earlier. So this is now a simple integration of e raised t dt. E raised t will always be e raised t, so e raised t plus constant of integration. Now t was taken as tan inverse x, so e raised tan inverse x plus a constant of integration is your final result. So this is the way you are going to write it. All these questions which we are doing are direct results. I mean, you know that differentiation we can give you the other part of integral, and it makes your life and question easier. So in this case, whenever you encounter an under root, this under root needs to be eliminated first. So we have trigonometry for that. We can just write x as say cos theta or x as sin theta or cos theta, any of it. So x equals to sin theta, when you put 1 minus x square will be 1 minus sin square theta. So 1 minus x square, 1 minus sin square theta here, and this will give you what? Cos square theta. And since we have an under root, actually plus minus cos theta will come, but let it be like this only. So integration of 1 by cos theta will come. Cos theta goes up, it will give you sec theta. So you can integrate sec theta. So this is not what we expect, because we have to differentiate also. X was sin theta. So we need to differentiate because we need to get rid of dx also if we are replacing it by some theta term. So dx becomes cos theta d theta. So now when you have cos theta, you don't have to worry about the denominator, because denominator we got cos theta already. Numerator also cos theta d theta. Now you can cancel this cos theta, only you have to integrate d theta. So theta will come, theta plus constant of integration. But theta was initially was x. If x is sin theta, theta will be sin inverse x. So theta becomes sin inverse x, and then you can write this. So write this sin inverse x here. So let's write it, sin inverse x plus a constant of integration. That's your final result. So this is how you're going to go about it. Use trigonometry. If you want to put x as cos theta, that also you can do, right? But there may be some other interjections. Now this is quite straightforward. Just multiply sec x inside. You'll get sec square x, you'll get sec x tan x, and you have directly the integration of these two terms. So I'm multiplying sec with sec x tan x. So the first will give you sec square x. The second will give you sec x tan x. Then you integrate these two. Sec square x will be tan x, and sec x tan x will be sec x only plus a constant of integration. This is your integration. So we need to solve it exactly like what I am presenting here. Now we have direct formulas like x square plus 16. When you have 4, 9, 16, 36, all these are squares. 2 square, 3 square, 4 square, 5 square. So you can use the formula directly. 1 by x square. 16 can be written as 4 square. So 1 by x square plus 4 square. Now this formula, we have 1 by x square plus a square. And you know that it is simply 1 by a tan inverse x by a. So 1 by a tan inverse x by a. In this question, a we will take it as 4, not 2. I'll just change that one. So this will be 1 by a, that is 1 by 4. 1 by 4 tan inverse x by 4 plus constant of integration. So this is the formula you are going to use. So again, a very straightforward question for you. Now don't worry about the under root. It just like x. X to the power 1 is x. X to the power half is under root x. So now multiply this inside. Root x into 1 will be root x. Root x into x will be x into root x. So that root x is simply x to the power half. You have x raised half dx. X under root x. So x to the power half. This is x raised 1. And 1 plus half is 3 by 2. So x to the power 3 by 2 will come. 1 plus half is 3 by 2. This is x raised 3 by 2 dx. Now let's integrate x raised. N is x raised n plus 1 divided by n plus 1 plus a constant of integration. This will give you x to the power half plus 1 divided by half plus 1 minus x to the power 3 by 2 plus 1 divided by 3 by 2 plus 1. Half plus 1 is 3 by 2. 3 by 2 plus 1 is 5 by 2. So x raised 3 by 2 divided by half plus 1 is 3 by 2. So let's write this 3 by 2 in the denominator. This 3 by 2 plus 1 will be 5 by 2. When it goes up, it will be 2 by 3. When this goes up 5 by 2, it will be 2 by 5. And you know that x to the power 5 by 2 is already there. This goes up 2 by 5 will be formed, and that will be plus constant of integration. This is your integration, final result. Now this is how you are going to do this. This is a simple classic example of integration of x to the power n. Just multiply inside and use this formula, and this is how you're going to write. At first glance, this question seems to be complicated, but it's not. Why? Just take the denominator, and when you take the denominator and differentiate it, are you going to get something related to the numerator? Let's see. We have 3x square plus sine 6x, which we have taken as t. Now let's differentiate it. dt by dx will be what? It will be 3 into 2 into x. So we are getting something here. 6x here. Then sine 6x will be cos 6x, and differentiation of 6x will be 6. So 6x plus 6 cos x, let's take 6 common. When you take 6 common, x plus cos 6x will come. Let's take 6 in the denominator. So what you see in the right is actually the numerator which we wanted. So x plus cos 6x dx is the numerator. So you can just write dt by 6 in this case. 1 by 6 can be brought in front of the integration sign. The denominator is a t. dt by t is log t. 1 by 6 is the precursor, or you can say the coefficient. So integration will be 1 by 6 and then 1 by 6 log modulus of what was t? 3x square plus sine 6x plus constant of integration. That's your final result. So this is how you can do it, and the best way to write is in this way. When you take 3x square plus sine 6x as t, all will be easier for you. Now this question and the next question are almost similar, and it is based on the formula which we have already proven. So integration of x minus 1 by x square into e raised x dx is fx e raised x plus constant. Write the value of fx. Now let's integrate this. X by x square, let's separate them out. X minus 1 by x square, it can be written as x by x square first, then minus 1 by x square. X by x square is 1 by x, this is minus 1 by x square. We have done a question like this in this exercise only. So e raised x is already there. 1 by x minus 1 by x square is just a form of writing x minus 1 divided by x square. Now you see that e raised x is already there, and fx, if you consider to be 1 by x, are you getting f dash x as the second term? Yes. F dash x is a negative 1 by x square. So this integration can be written as e raised x fx, which is this one, and then f dash x. So just add it and f dash x will come, and this is equal to fx e raised x. So the direct result of this integration is what? Fx into e raised x. What is fx here? Fx is 1 by x. That's what we have started with. Fx is 1 by x. So just write 1 by x, and this is equal to fx e raised x plus c. Now equate these two. So when we equate, 1 by x is actually the fx. The function is 1 by x, which you can write like this. This is your final result. So as you see here, the directions I gave you is exactly like this, but the English-like thing and the explanation should be like this. This question is no different from the previous one, because already you know that this question has been done in the previous few questions. So just multiply this sec x inside with 1 plus 10x. So first we'll write this sec x, and then we'll write sec x 10x, which eventually will come when we multiply 1 plus 10x with sec x. Now in this is the exact result of a standard. This standard is e raised x fx plus f dash x. So the direct result of this integration is fx e raised x plus a constant of integration. Now when we equate this, what was taken as fx? Sec x. Because if you take fx as sec x, then you differentiate it, that is f dash x, it should come as f sec x 10x. So f dash x sec x is sec x 10x, which we already know. So that's why e raised x fx is the result which will come, but the question is asking only about fx. So the fx is simply sec x. The answer of this question is fx equals to sec x. So again, the same approach which we have used in the previous question, which is the 56th question. Now integration of 2 by 1 minus cos 2x. 1 minus cos 2x can be directly changed into, because we know the formula, it will be 2 sine square x. 1 plus cos 2x is 2 cos square x. So when we write 2 sine square x here, 2 gets cancelled, sine square x goes up. This will be cosec square x. And cosec square x dx has a direct result, which is minus cot x. So no assumption, nothing, just minus cot x plus constant of integration. This is your integration. Now the reference, if you see here, it's 1 minus cos 2x will give you 2 sine square x. cosec square x minus cot x. Now write the antiderivative of 3 root x plus 1 by root x. See, this question is quite easy for you, but the question is asking antiderivative. Sometimes people may get carried away or try to understand what is this antiderivative. Antiderivative is nothing but integration. Anti-integration is derivation. Like you can understand like that. So this is, let's separate them out. So integration of 3 root x will do separately, and we'll separate out this 1 by root x also. So we have plus 1 by root x integration dx. So 3 root x is 1, x to the power half is simply x to the power half plus 1 divided by half plus 1. So we get x to the power 3 by 2 divided by 3 by 2, it goes up 2 by 3, 3 get cancelled. So the first term will be only 2 into x to the power 3 by 2. Now the second term 1 by root x, let's do it. So I've written 1 by 2 root x, it's wrong. Let me do it again. So x raised minus half, x raised minus half plus 1 divided by minus half plus 1. So this will be x to the power half, and this is half, 2 goes up. So 1 by root x, the result is twice of root x. So this just write 2 root x here, and again a plus constant of integration, which is very important. So let's write the formal answer. It will be 2, you can take 2 common, x to the power 3 by 2 plus x to the power half plus a constant of integration. Now if you want to understand how this can be written, this is the reference solution for you. You can follow this. Now we have cos inverse sine x. So we just need to cancel this inverse, and sine can be converted into cos term, which we already know. Sine 90 minus theta is cos theta, cos 90 minus theta is sine theta, we already know that. So this is sine theta, it will be cos 90 minus theta. Similarly, if you do sine 90 minus theta, it will be cos theta. So this 90 can be written as pi by 2 in radians. 90 degree is equal to pi by 2 radians. So cos inverse in place of sin x, I'm writing cos pi by 2 minus theta. So cos inverse goes, pi by 2 remains with a theta. Now what you can do is you can just separate these two term out. Pi by 2 separate and x separate. It's not theta actually, it's x. I just showed you theta for a reference. So pi by 2 goes out, integration of dx, then we have x dx. So pi by 2 dx is x only, and this will be x square by 2 plus constant of integration. This is your I. Now you need to know how to write this, because all those things which I say, it needs to be penned down also, and this is how you are going to write it cleanly. 1 by sin square x cos square x. Now sin square x cos square x is simply sin x cos x whole square. Now you can have a 4 in front of this in numerator and denominator. With that, the purpose we are going to solve is, if you have 4 numerator denominator, this 4 can be taken inside. It will be 2 sin x cos x whole square. So we have 2 sin x cos x whole square, and this 4, actually this 4 is 2 with a square. So 2 sin x cos x is sin 2x. So we have 4 divided by sin 2x whole square. And when it goes upstairs, see, sin 2x is cosec 2x, and sin square 2x will be cosec square 2x. And you know that cosec square theta has a direct integration. 4 comes out, cosec square x 2x dx, whatever is inside doesn't matter to us, because we are more interested in minus cot 2x, which will come. 4 is already there, and then we have 2x. This also needs to be differentiated, and it has to be kept in the denominator. So this gets cancelled, 2, so minus 2 cot 2x will come. Let me write the final answer here. Minus cot 2x and then a 2 in front. So minus 2 cot 2x plus constant of integration is your final result, which gives you an I. Okay. Now this sin cos just have to be changed into this sin 2x, and then rest will be easier. So this is how you're going to write it with all the formulas, etc. Now this question is quite evidently solved previously. 1 plus log x will give you 1 by x. You already know that. So just take t equals to 1 plus log x. Differentiate it, dt by dx will give you 1 by x, that is dx by, this dx can be brought in the right. So dt gives you dx by x. Now dx by x is already in the question. It's not dx by x, dx, sorry for that. It's just dx by x. So dx by x can be written as just dt. 1 plus log x was taken as t. So dt by t, which is log t in the modulus plus constant of integration. Log in place of t, replace it by 1 plus log x. Write 1 plus log x plus a constant of integration. It's your final result. Okay, this is how you're going to go about it. I think we are quite clear about these kind of questions now. So this is all about this exercise. Thank you so much. Have a good one.